Welcome everyone. This is Ahmed Bashir. I am a PhD scholar at Delhi College of Commerce and a faculty member at Department of Commerce, University of Gujarat. In my previous session, I was discussing about the fifth assumption of regression, that is uh, testing the assumption of outliers. So I am again repeating the same assumption because this particular assumption was not complete in my previous session. So the assumption is basically there should be not a significant outlier in the variable of interest or data set. So always remember, if you identify an outlier, then you need to see whether this outlier is significant or not. So if the outlier is found, but that outlier is not significant, in that case, we can say that this outlier is basically not significant. That's why it is not violating the assumption. So always remember that there should be no significant outlier. If significant outlier is found, then the assumption is violated. So I have discussed there are three methods. The first method is frequency method, the second method is explored method, and the third one method is the standardized value or z-score method. So I have discussed the first one in my previous session. Today I am going to focus on explore method and standardized z-value method. So let me discuss it for your convenience. Let me take this example in order to elaborate our explore. Internet was interrupted. Now I am starting again. I was discussing that suppose that we have the annual income data in thousands for 15 individuals. So here 18 mean 18,000, 24 mean 24,000, and 26 mean 26,000, and so on. So these are the annual income of 15 individuals. So in order to test the significance of outlier, whether the outliers are significant or not, we need to follow this procedure. We need to go to analyze, then descriptive statistic, then explore. In the new window that pops up, drag the variable income into the box labeled dependent list, then click statistic and make sure the box next to percentile is checked. Then click continue, then click on OK. If there are no circle or asterisk on either end of the box plot, this is an indication that there is no outlier present. So let me show you the procedure with this data. First of all, we need to open the IBM SPSS in order to evaluate this procedure, because this procedure requires to have a data set in order to comply with this procedure. And always remember that you need to identify two things. The first thing is the outlier, and the second thing is asterisk sign. If you find the outlier along with asterisk sign, it means it is a significant outlier. And if we identify the significant outliers, then it is the violation of our assumptions in our data set. So let's suppose we have the income data, and we need to consider it as a scale variable because it is a continuous variable data. So what we need to do, we need to put this data here, 18, 24, 26. So we can manually put it 18, 24, 26, then 34, 38, 45, 34, 38, 35, 34, 38, 35. Oh, sorry, this is 45, not 35. So we can make it 45 after 38, 34, 38, 45, 48, 54, 60, 48, 54, 60. And then we need to calculate. 73, 79, 73, 79, 85, 94, 85, 94, and 98, 108. 98, 108. Now, this is the annual income data of 15 individuals. If we want to remove the two decimal places from here, we can go here and we can remove two decimal places. Now it is without decimal places data. So what we need to do now, we go to analyze descriptive statistic and explore. So go to analyze descriptive statistic and explore, and we need to put it into the dependent list. After doing it, what we need to do, click on statistic and make sure the box next to percentile is checked. So click on statistic, next to percentile is checked, outlier. So continue and click OK. So it will indicate me whether the outlier is present in the data or not. So you can see here, if there is no outlier, there will be no any point that you will find here. So there is no out. Again, there was an interruption of internet. So if you do not found any circle on the upper side, on the lower side of this box plot, then there is no outlier. And if you found a circle with steric sign, then there is a significant outlier. So here in this case, there is no significant outliers. There is no outliers actually. So this is not the violation of the assumption. So what if the outlier is found? If outlier is found, then there are some remedial measure that we can apply in order to remove that outliers. I will let you know those measures. First of all, I need to show you the whole procedure that I have elaborated here. So this is the procedure that I have find out right now. So let's suppose there is also the indication of your quartile data. If you see in our results here, you can also find here the percentile results here. Now, if you see here, there is 5 percentile, 10 percentile, 25 percentile, 50 percentile, 75 percentile, 95 percentile, 90 percentile. So if you see here, the income level hinges data is found in first quantile or 25 percentile, the second quantile or 50 percentile, and 75 percentile or third quartile. This is known as third quartile, this is the second quartile, and this is the first quartile. Now, what does it mean by why they are important to understand? First of all, you need to understand these ranges. The first quantile or 25 percentile of your data is known as Q1. The second quantile or the 50 percentile of the data is known as Q2. The 75 percentile or third quartile of your data is known as Q3. So SPSS consider any data value to be an outlier if it lies outside of the following ranges. So if your data basically goes to outside of the following ranges, then you can consider it as a as a outlier. So third quartile plus 1.5 into interquartile range, first quartile minus 1.5 into interquartile range. So this is the third quartile. And here the value you have given, you need to plus 1.5 into interquartile range. What does it mean by interquartile range? When you subtract Q1 from Q3, it becomes interquartile range. So whenever you add 1/5 of interquartile range into the third quartile and minus 1/5 of interquartile range from the first quartile, and if you found something, it will become the outliers here. So graphically, what does it mean by outliers? You need to understand what does it mean by outliers in the graphical shape. So this is the Q1, this is the Q2, and this is the Q3. So anything if you find out outside of the Q3 and outside of Q1, any dot you find out is the outlier. But the steric sign with that outlier is the significant outlier. So we can calculate the interquartile range by taking the difference between third quartile and the first quartile. The third quartile is 75 percentile and the first quartile is 25 percentile in the row labeled Tucky's hinges in the output. So for this data set, the interquartile range is 82 minus 36 because we need to subtract 36 from 82. So it will indicate us 46. It is an interquartile range. Thus, any value outside of the following range would be considered outlier. So 82 plus 1.5 into 46. When you take 1/5 of this value and you add into 82, it will indicate you 156. So if you find any value which is equal to 151 or maybe greater than this range will becomes the outlier. Similarly, if you subtract 1/5 of this interquartile range from the first quartile, it will also indicate minus 33, which will become the outlier in our data. So obviously, income cannot be negative, so the lower bound in this example is not useful. However, any income over 151 would be considered an outlier. So, how can we test this? There is a simple procedure. For example, suppose the largest value in our data set is 152. Replace your 15th value in data set with 152 and rerun the procedure. So, what we need to do, we go to our data and we replace our value with 152 because our interquartile range indicates that we can have an outlier against the value which is greater than 151. So 152 is the value which is greater than 151. So we put here as a last value 152. So what we need to do, we go to analyze, we go to descriptive statistic, we go to explore, and we apply the same procedure that we have done and click OK. Now you will see here there is an outlier. It is indicating that the 15th observation is an outlier, but still there is no steric sign here. That is why we cannot call it a significant outlier. Always remember that an outlier would be considered the significant outlier if you find out an asterisk sign over here. So let's suppose we put here, if we see here a value, if we see here a value which is greater than this, and I need to show you something from here. SPSS also consider any data value to be extreme outlier if it lies outside of the following range. So we calculate the range again and we find out that 220 would be the maximum range. So if we put here 221, what will happen? So let me show you again here. So instead of putting 152, 221, we put 221 here, and we go to analyze, we go to uh, descriptive statistic, explore, and run this procedure. Now, if you see here, you will find a value with steric sign or with star sign. Now, this is a significant outlier. So, whenever you find uh, a dot here, a circle here without star sign, it is not a significant outlier. There is no violation of the assumption. But if you find out this star or some steric sign with some value, the value which is indicated here is the number of observation. It means the 15th number of observation here is basically the outlier. The simple rule using this method is to remove this value from here, and it will remove the outlier from your data. So any value which is shown with the star sign or steric sign is a significant outlier. In that case, we say that our assumption is being violated. So what is the remedy if outlier is detected? What we need to do if some outlier is detected? So if an outlier is present in your data, you have a few options. Make sure the outlier is the not result of the data entry error. Sometimes we make some mistakes in data entry. So we need to verify whether it is a data entry error or not. So sometimes an individual simply enters the wrong data value when recording data. Instead of putting 25, we put 52 in the reverse order, and it becomes an outlier. So if an outlier is present, first verify that the value was entered correctly and that it was not an error. The second thing is the remove the outlier. If the value is true outlier, you may choose to remove it if it will have a significant impact. Significant impact means if it is appearing with steric sign or with star sign, it is a significant outlier. In that case, you need to remove it. On your overall analysis, just make sure to mention in your final report or analysis that you have removed an outlier. The third one is assign a new value to the outlier. If the outlier turned out to be result of data entry error, you may decide to assign a new value to it, such as of the data set. So always remember that if you find out the reason why you have an outlier, always try to understand that if it is due to the data entry error, or if you know the actual value, always try to replace that value with the actual values mean or median. So for example, if I see here, I need to take the mean of the whole of the data, or I can take the median. So simply stating, I go to analyze, go to descriptive statistic, go to descriptives, and put it here because I need only the mean value. I doesn't require here the any other value. I just need the mean value. So it will give me a mean value of 66.47. So I can place here the value 66 in order to remove the outliers of the data. So now if I check it, it will give me an error-free outlier. Click on OK. And now you can see here, there is no outlier here. So this is the remedy that you can apply if you find some error. You just need to replace your variable or your value, which is actually indicating an outlier. You can place here the mean of the range. So through the method that we have applied here. The third method that we need to understand here is basically the z-value method. Now this value, this method is also very popular, and you need to understand is how to identify the outlier using this method. This method is known as Z-score method. So analyze descriptive, then descriptive, put your variable of interest in the relevant box and check the save standardized value as a variable and press OK. Now go to the last column of your data view, which is showing Z value of your variable. Just right click and sort descending. If you find any value greater than 3.3 or minus 3.3, it is an outlier that need to be corrected. So let me show you the method. Let me show you the previous value. The previous value here was 222. Sorry, 220, yes, 222. So let me perform this method. I go to analyze, go to descriptive, then again descriptives. I put my variable of interest and check the save standardized value as a variable and press OK. So I go here, I go to the option. No, this is the option, save standardized value as a variable. Click on it, check it and click OK. Now, what is basically indicated here? If you see in the data set, a new column has been generated with Z income value. So what we need to do next? Now go to the last column of your data, which showing the Z value of your variable. Just right click and sort descending. So what I need to do, I go here, I right click on it, and I need to sort descending, this option. Click on it, and it will indicate a value 3.1. So what if you find any value greater than plus 3.3 or minus 3.3, it is an outlier that needs to be corrected. If you see here, there is a value of 3.1, which is close to 3.3. So we can say this is the outlier. So we can remove this outlier. We can take the mean as we have done previously. Just simply put here the mean of your range and clear this column. So again, we have put it here, the mean value, and if we check it, it will not indicate the z-score close to 3.1 or 3.3. So again, I put it here. I go to descriptive statistic, then descriptive, then save standardized value and click OK. And again, I will see the data set. Right click and sort descending. And here you can see there is no value which is close to 3.1 or 3.3. So we can say there is no outlier here. So this is the method. These are the methods that you can apply to detect the outliers. Now, the last assumptions that we need to test here is the testing the absence of heteroscedasticity. How to test the absence of heteroscedasticity? What is the procedure? So first of all, you need to understand what is the heteroscedasticity here. Uh, Homoscedasticity, the opposite word to heteroscedasticity, means that the variance of the error should be equal at all levels. So the variance of the error or the residual should be constant across all levels of the independent variables. In other words, the spread of residuals, spread means variation. So whenever the variation of the residual is the same throughout the range of independent variable, it is known as homoscedasticity. So in this case, the model is satisfactory and there is no violation of the assumption. But if you find that the residual against that the residual is not equal across all level of your data, across all parts of your data, and it look like this, then it is the case of heteroscedasticity. Heteroscedasticity means that the variance is not equal at all levels or all independent variables or all points of independent variables. In that case, it is an unsatisfactory model. So how can we test whether the heteroscedasticity is absent or not? So there are the procedure that you need to understand using SPSS in order to find out whether there is heteroscedasticity in the data or not. So graphical method includes analyze, regression, linear, put your DV and IV in the required places and click on the plot button. Now put Zepi red in axis and Z resided in Y axis. Check the boxes of histogram and normal probability plot. Uh, Continue and then finally, okay, now check the scatter plot. Always remember, in order to check the absence of heteroscedasticity, you need to have a dependent variable as well as an independent variable. So in order to verify this assumption, I need to open another data set. For example, I need to close it and I need to open another data set. For example, this one, as this one is already shared with you. So I am going to open this data set for your consideration so that you can understand the procedure optimally, and you need to apply this procedure for your analysis. So this data set is going to open. From this data set, we have already using GPA as an independent variable and total marks as a dependent variable. So we go to analyze, we go to regression, then linear. We need to put GPA as an independent variable and total marks as a dependent variable. And after placing these two, what we need to do, we click on the plot button and put ZP red in axis and Z residual in the y-axis. So we go to plot. Yes, this button, ZP red. This is ZP red. You need to put it as a axis and Z residual in the y-axis. Basically, residual is is the residual is the error term, which is always calculated using the dependent variable. So always put the Z residual in the y-axis and Z predicted. This is Z predicted. It is put it in the x-axis. So what we need to do next, after doing this, check the boxes of histogram and normal probability plot. All right. So we go to the boxes of histogram and normal probability plot. These two should be checked. And after doing this, continue and then okay. Now check the scatter plot shape. All right. So after doing this, we have put it ZP red in the x-axis, Z residual in the y-axis. We have checked histogram, normal probability plot. Click on continue, then click on OK and check the shape of your normal probability plot. So the charts are creating. Now, this is the shape. If you see this shape, it is indicating the scattered graph. It is indicating the scattered graph. And if we see with our data, it is not showing any linear shape. It is showing a similar shape like this. But we can, if we cannot decide it, there might be another method which we can apply, which is known as Bruce-Pagan test. Bruce-Pagan test. It is used. It is a known graphical procedure which you can apply in order to confirm whether there is a heteroscedasticity in the model or not. So let us uh, understand this procedure. There is no direct procedure to estimate heteroscedasticity using Bruce-Pagan test. However, we can indirectly estimate this test in 3 steps in SPSS. As a first step, you need to estimate the residue. And secondly, you must take the square of residues and make it squared residue. Then thirdly, you will run the regression to test the heteroscedasticity using Bruce-Pagan test. So what are the steps? First, you analyze regression linear, put your DV and IV in the relevant part, use save button for generating residual, standardized residue. So let us run this procedure. This is non-graphical procedure because if you cannot decide based on the graphical procedure that whether the assumption is met or not, you can go to the non-graphical procedure, which is Bruce-Pagan test. So go to regression, go to linear, and first of all, you need to put it back, which you have previously done. And what we need to do now? So we need to go to save button and we need to generate the standardized residual now. So we go to the save button here, save button. This is the save button. And we go to residues and we need to generate the standardized residual here. So click continue and then click OK. After doing it, if you see your data, you need to see your data here and go to the right side. You can see here that you have generated a z-score, a standardized z-score data. Now, after doing this, what we need to do, take the square of your standardized residual using transform compute variable, write SQR in the target variable and write ZRE multiply by ZRE in the numerical expression part and click OK. All right. So we go to transform, we go to compute variable, we go to SQR square square residual, square residual. For example, this is the square residue. So how can we compute it? We just need to multiply this one with its own self. So for multiplication, this steric sign is used. So again, put it here. So uh, I have multiplied standardized residual with its own self. So click on OK. So it will compute the square of residual and you can see it here. Now this is the square of residue. After calculating it, what we need to do next? If we see here, take your squared residual as the dV and regress it by taking the same IV that you have used in step 1. So in step 1, I have used GPA as my IV. So now what I need to do, I go to analyze, go to regression, go to linear. Now this is the same IV that I have previously used, but this time I need to take the square of residual as a dV. So I don't need to generate the standardized residual again. So click on OK. Now your regression has been computed. So what I need to do here, there are some guidelines here that you need to understand when you have run the procedure. You need to check the ANOVA table after model summary. If the sig value is greater than 0.05, it is homoscedasticity. But if the sig value is less than 0.05, it is heteroscedasticity. So we need to see the ANOVA table. This is the ANOVA table. If sig value is greater than 0.05, it is if sig value is greater than 0.05, it is homoscedasticity. So here the sig value of ANOVA table is greater than 0.05. So this is homoscedasticity. If this value is less than 0.05, then it is heteroscedasticity. So this is the indirect procedure. It is known as Bruce-Pagan test. So if the independent variable is significant with the square root with the square of your residual or your standardized residual, then it is known as that there is heteroscedasticity in your data. But if the sig value is greater than 0.05, then we can say that assumption is not violated. In that case, there is no heteroscedasticity in the data. So as the sig value is greater than 0.05, so we can conclude here that there is no heteroscedasticity in this data. So this is how you can compute the heteroscedasticity in your data. So if you find the heteroscedasticity in your data, then you need to regress a robust regression. Then that I will let you know in the upcoming sessions of the following week. So this is all about the regression assumptions that we have discussed. We have discussed in detail the regression assumptions, linearity of IV and TV, normality of residual, independence of error, absence of multicollinearity, absence of outlier, and absence of heteroscedasticity. So this is all about the assumptions of regression. In tomorrow's session, we will discuss the regression cases, and we will cover some part of it tomorrow, because tomorrow is the last working day of this week. The remaining part we will cover in the next week. So do you have any question, Ms. Hina or Ms. Rabia, about today's session?
No, sir.
All right, Ms. Hina, do you have any question?
Sir, actually, I have joined late, so I will see the whole video and then I can conclude.
All right, all right. So do some practice. I will share the recordings of this video. So you need to do practice, and if you feel anything, if you find any question or confusion, you may ask me. So thank you very much for joining for today's session. Let's meet tomorrow for the other topics. So thank you very much.